Today we're going to begin our discussion of rational expressions. A rational expression is defined as a polynomial numerator over a polynomial denominator. So all the work that we have done in chapters 5 and 6 with polynomials will play a big role in this chapter on rational expressions. Our first skill, when is a rational expression undefined? Meaning it doesn't make any sense? And the answer is when the denominator equals 0. We are never in math allowed to zero out the denominator of a fraction. So here are a couple of rational expressions. I have 3x plus 2 over x squared minus 5x minus 14. I also have x minus 3 over x squared minus 9. And the question is, when are they undefined? Okay, so let's tackle this. When would this denominator equal 0? Well, we could actually move it over here and say, well, when would x squared minus 5x minus 14 equal 0? And suddenly we have a problem from the last chapter. I could factor this, x, 7 and 2 minus 7 plus 2. That will factor. So then when x minus 7 equals 0, or when x plus 2 equals 0. So when x equals 7, or when x equals negative 2, this rational expression will be undefined. Okay, let's take another one. When will this rational expression be undefined? Well, it will be undefined when x squared minus 9, the denominator, equals 0. That would be x plus 3 times x minus 3 equaling 0. So x plus 3 equals 0, or x minus 3 equals 0. So when x is negative 3, or when x is 3. What about when would x minus 3 over x squared plus 9 equal 0? Well, that would equal 0 when x squared plus 9 equals 0. We don't have a factoring strategy for x squared plus 9. In fact, x squared plus 9 is prime. It will not factor. I could show you if I just subtracted 9 from both sides, I'd be saying that something squared equals negative 9, and that never happens. When I square things, they become positive. So this denominator will never equal 0. So there are no places where this is undefined. Okay, let's go again. What about x squared plus 9x equals 0? Well, I do have a factoring strategy for that. Greatest common factor. X times x plus 9 equals 0. So when x equals 0, or x plus 9 equals 0, so that's x equals 0, or x equals negative 9. Okay, so those are the techniques that I use for finding where a rational expression is undefined. Here's our other skill for today. Putting a rational expression into lowest terms or simplest form, which you have done with regular fractions all your life. So here we have 27x squared, a monomial numerator, and 3x, a monomial denominator. When I have a monomial numerator and a monomial denominator, this goes right back to the beginning of chapter 5, and we can just 3 and 27, and x squared divided by x, so x to the 2 minus 1. So this would just be x. So my answer would be 9x is lowest terms. It's a little different when I have a binomial numerator or a trinomial numerator or a four-term polynomial numerator. I can't cancel in pieces like I did over here. With monomials, sky's the limit. With binomials, trinomials, etc., you can only cancel identical pieces. So what we end up doing is factoring 8 times y minus 3 over 4 times y minus 3. Okay, so this is the numerator in factored form. This is the denominator in factored form. So now I have an identical binomial. That I can cancel. It is also true that now I have a monomial 8 over a monomial 4. So my answer here is 2. Again, the difference between monomials, cancel in pieces, binomials, trinomials, not so much. Okay, so here we have a trinomial numerator and a trinomial denominator. I can't just cancel the 4s and then cancel the 8x and the 4x. I can't cancel in pieces. The temptation is to do that, but please do not. It's like kidnapping people from their homes. These trinomials, these 3 terms, they belong together. And the only way I can cancel is if I can factor. Okay, so I'm going to try and factor. So that's 12. A little scrap work here. So 1 and 12, 2 and 6, that's the pair I want. So my numerator looks like 3x squared plus 2x plus 6x plus 4. A little bit of grouping. We've got x times 3x plus 2 plus 2 times 3x plus 2. So then I've got 3x plus 2 times x plus 2. That's my numerator. So my numerator is 3x plus 2 with x plus 2. And I am going to get rid of my scrap work. My denominator is negative 12. So that's 1 and 12, 2 and 6. Now I want 2 with negative 6. So 3x squared plus 2x minus 6x, oops, minus 4, minus 4, x, 3x plus 2, negative 2, 3x plus 2. So my denominator is 3x plus 2 with x minus 2. Let's get rid of all this. Okay, what do I have now? I have identical factors of 3x plus 2, so those will cancel. These are not the same. X plus 2 is not the same as x minus 2, so in simplest form, I have x plus 2 over x minus 2. Here's an interesting case. We have 2 minus x over x minus 2, and one would think, well, those are the same or they're not the same. Actually, the numerator is, if I write it in standard form, negative x plus 2 over x minus 2, so they're not the same. But if I factor a negative 1 out of the numerator, I can turn it into x minus 2, and my denominator is x minus 2. So now those are identical. So this simplifies to negative 1. So be on the lookout for something that is not in standard form, and so we can factor out a negative 1 and perhaps make something happen.